Hello students, today we are going to discuss the very important concept of chemical bonding, that's hybridization. It is very important concept in the whole inorganic chemistry. Now, before defining hybridization, we will first try to understand why the concept of hybridization was introduced. We have already studied valence bond theory. Actually, hybridization is the advanced form of valence bond theory. Firstly, we will try to understand why the concept of hybridization was introduced. So, we will take an example of methane CH4. We will apply the concept of valence bond theory on this methane, formation of methane. In this CH4, carbon is central atom here. The atomic number of carbon is 6 and its electronic configuration is 1s2, 2s2, 2p2. This is the electronic configuration of carbon, which is central atom in this methane. We are actually applying VBT on this CH4. We will explain the formation of CH4 with the help of VBT. So we are actually applying VBT, valence bond theory, on this CH4 molecule. So if we see the outer shell electronic configuration of carbon here is 2s2, 2p2. So we will make an orbital diagram here. This is 2s2 and 2p2. 2s2 and 2p2. Outer shell electronic configuration of carbon. Now, because outer shell takes part in bond formation, according to VBT, only half-filled orbitals take part in bond formation. So if we check here, this is the ground state electronic configuration of carbon. So in this ground state, the carbon atom has only two half-filled orbitals. It means that carbon atom can only form two bonds. But when we see CH4 molecule, in this molecule, carbon is forming four covalent bonds with four hydrogen atoms. So this means that the formation of CH4 molecule is not possible in the ground state of carbon atom. So what we will do, the pure orbital of this carbon will get promoted to here. Excitation will take place and the excited state electronic configuration will be like this. One electron goes here and the resulting electronic configuration will be like this. This is the excited state electronic configuration of carbon. This was the ground state. Now, when we check the excited state, in the excited state of carbon, there are four half-filled orbitals. It means four covalent bonds can be formed. So this means that CH4 can be formed in this state, excited state, not in the ground state. Because in the ground state, there are only two unpaired orbitals. Now when we check, these are the four unpaired orbitals. These four unpaired orbitals of carbon will overlap, according to VBT, will overlap with four s orbitals of hydrogen atom to form four covalent bonds. Now this is the s orbital of one hydrogen atom. This is the s orbital of second hydrogen atom, third hydrogen atom and fourth hydrogen atom. The electronic configuration of hydrogen is 1s1, like this. These are the four s orbitals of four hydrogen atoms respectively. So what will happen? The 2s orbital of carbon and 1s orbital of hydrogen will overlap to form one sigma bond. Second, 2px orbital of carbon and 1s orbital of hydrogen will overlap to form second covalent bond. 2py orbital of carbon and 1s orbital of hydrogen will overlap to form third covalent bond, and 2pz orbital of carbon and 1s orbital of hydrogen will overlap to form fourth covalent bond. So when we see the four covalent bonds are formed here, so when we check this, the s orbital of carbon and s orbital of hydrogen, it means this bond is formed by ss overlap. Here s orbital of hydrogen and p orbital of carbon, this means this bond is formed by sp overlap. Again, s orbital of hydrogen and p orbital of carbon, that means it is also formed by sp overlap. Again, s orbital of hydrogen, p orbital of carbon, that means it is also formed by sp overlap. So when we check these four bonds, in these four bonds, one bond is formed by ss overlap and other three bonds are formed by sp overlap respectively. According to valence bond theory, the bond formed by sp overlap is stronger than the bond formed by ss overlap. This means that these three bonds must be stronger than this bond because it is formed by ss overlap. So, but experimentally, when we see, the experimental analysis shows that all the four CH bonds in the CH4 are equally strong. So there is the difference between the observed result and the experimentally determined result. So to explain this concept, the concept of hybridization was introduced. Because when we apply VBT on this, so according to VBT, the bond formed by sp overlap must be stronger than the bond formed by ss overlap. But experimentally we see that all the four bonds in the CH4 are equally strong. So to explain this concept, hybridization was introduced by Linus Pauling. So how we will explain this concept with the help of hybridization? Now the same CH4 story is explained with the help of hybridization. Now, in this state, CH4 is formed. This is 2s orbital, 2px, 2py and 2pz. So, we will see like this. This is 2s orbital. The shape of s orbital is spherical. The s orbital or 2s orbital plus px, py orbital and pz orbital. These are the four orbitals, 2s, 2px, 2py and 2pz. This is 2s orbital because the shape of s orbital is spherical. This is 2px orbital. The shape of p orbital is dumbbell shape. This is 2py and this is 2pz. This is 2s orbital, 2px orbital, 2py orbital and 2pz orbital. These are the four orbitals of this carbon. Now, what will happen? Now, the Pauling says that before the bond formation, these atomic orbitals of the valence shell intermix with each other. The bond is not formed. Bond is not formed. Actually, what happens? Before the bond formation, these atomic orbitals of the valence shell of this carbon intermix with each other. These atomic orbitals have different shape and different energy. Now, when these atomic orbitals will mix, they will form new type of orbitals, and those orbitals are called as hybrid orbitals. So these atomic orbitals of different shape and different energy will intermix with each other and they will form new type of orbitals, and those orbitals have same energy and same shape, and those orbitals are called as hybrid orbitals. And the number of hybrid orbitals formed is equal to the number of atomic orbitals mixed. So how many atomic orbitals are mixing here? 1, 2, 3 and 4. 4 atomic orbitals are getting mixed, and these 4 atomic orbitals will form 4 hybrid orbitals, and the hybrid orbital is represented like this. Why it is represented like this? Simply, if this is s orbital and this is p orbital, when they will mix, these 2 lobes will form a bigger lobe, and this will form a smaller lobe. Electron density on the one side will be more. So hybrid orbital is represented like this, and this hybrid orbital is called as sp3 hybrid orbital, because it is formed by 1s orbital and 3p orbitals. This hybrid orbital is called as sp3 hybrid orbitals. sp3 hybrid orbital. And how many sp3 hybrid orbitals will be formed? 4. Why? Because 4 atomic orbitals are getting mixed. So 4 sp3 hybrid orbitals will be formed. Now, the bond is formed by these hybrid orbitals, not atomic orbitals. So what Pauling says, that bond is not formed by these atomic orbitals. What happens? These atomic orbitals first intermix with each other, and they form new type of orbitals, and those orbitals have same shape and same energy. And these orbitals are called as hybrid orbitals. And now what will happen? These hybrid orbitals will take part in bond formation. Now this sp3 hybrid orbital will form bond with 1s orbital of hydrogen atom. Again, second bond, again 1s orbital of hydrogen atom, 1s orbital of hydrogen atom, and 1s orbital of hydrogen atom. So what will happen? These 4 sp3 hybrid orbitals will overlap with the 1s orbital of 4 hydrogen atoms respectively. So what will happen? The 4 bonds in this CH4 are now formed between sp3 hybrid orbital and 1s orbital. So there is sp3s overlap. So all the 4 bonds are formed by a similar type of overlap. So we can now say that, so there is the evidence that why the 4 bonds in the CH4 are equally strong. If we will explain this concept with the help of VBT, we are not able to explain why these 4 bonds are equal. Because according to VBT, the bond formed by SS overlap must be weaker, and these 3 bonds must be stronger than this bond. But experimental evidence shows that all the 4 bonds are equally strong. Why these 4 bonds are equally strong? This is explained by the concept of hybridization. So what happens? The atomic orbitals of the valencia, these atomic orbitals are differentiate in different energy. They intermix with each other and they form new type of orbitals, and those new type of orbitals are called as hybrid orbital. Now the bonds are formed by hybrid orbitals. So this intermixing of atomic orbitals to form hybrid orbitals, this process is called as hybridization. So this is simply why the concept of hybridization was introduced. So simply the intermixing of atomic orbitals to form hybrid orbitals, this is called as hybridization. And how many hybrid orbitals are formed? Number of atomic orbitals mixed is equal to the number of hybrid orbitals formed. So that is why the concept of hybridization was introduced. So this concept of hybridization is actually the advanced form of valence bond theory.